Okay, no, not really. So remember this: like poles always repel each other, always.
Uh-huh.
Okay. So whenever two poles, for example, south south or north, they will always repel each other. Okay. And
Yes, sir.
unlike poles, will always attract each other. Okay.
Yes, sir.
You see an example here. Here we have kept a magnet which has a south
Uh-huh.
pole here and which has a
Uh-huh.
north pole here. So these two will
Attract.
attract. Have you seen any time you take two magnets and they will repel at the corners when you try to push them? They'll just repel. Have you seen that?
Yeah.
Yeah.
Yeah,
So,
I've
so,
seen.
so that means that this end and the other end of the magnets are of the same poles. That's why they're repelling
Yeah.
each other. If they're
Yeah.
attracting, that means they're of the opposite pole. That is, one
Different.
is north and one is south. But let's say you have a magnet, or let's say you have a magnet here.
Yes, sir.
This magnet which is in front of you, I break it into two halves. I
Yes,
take a
sir.
hammer and break it from the center. Okay.
Uh-huh.
So as you know, this will get into two halves like this: one
Yeah.
north here and one magnet here.
South.
Yeah, one south here. So this as had north here, and this will have south.
South.
Now, what will happen to this end? What will happen to this end? What poles will they have? Any idea about that? No.
No, sir.
Okay. Okay. So remember this: that whenever you break a magnet, okay, from half,
Huh? Huh?
it forms two more new magnets. That means that this magnet is a one more new magnet being formed, and this is a one more new magnet formed. So as we know that any magnet will have a north and a south. So since it already
Yeah.
has a north, so it will form a south here.
South.
And since there's one more new magnet we formed here, and since this already
Will
has a
form
south,
a.
so this will become north here.
Uh-huh.
Did you get it? So any
Yes, sir.
magnet when you break. So next is magnetic field. Okay. So
Yeah.
let's talk about what's a magnetic field. I just asked you a question. Now let's say you have a table in your house, okay, and on the
Yeah.
center of the table you have kept a small magnet, okay,
Yeah.
and there are some iron nails you have in your hand, and you know
Yes.
that the iron nails get attracted to the
Magnet.
magnet. Okay, so for example, if I keep some iron nails here, what will happen? These nails will get attracted to
Get
the
connected.
magnet. Cool.
Iron. Yeah.
For example, now let's say I remove the iron nails, and I
Huh?
have only the I have removed the iron nails. Okay, I took
Yeah.
all the iron nails from the table,
Hmm.
and I kept it here. Okay.
Hmm.
Now there are chances that some of them might get attracted because you know that I'm sure you would have experienced it that as you go far from the uh, magnet, the force reduces. I guess.
Yeah, and it won't get attracted.
Yeah, yeah, yeah. So there are chances that few of the nails might get attracted. Okay, a few of the
Yeah.
nails, not most of them will get attracted. Okay.
Only few of them.
Yeah. But what is from here which are kept here? I took them
Uh-huh.
and I kept it at the corner of your room. Okay, the magnet
Yeah.
is still placed at the center of the table. You
Table.
do you think the magnet can attract those nails?
No. No.
No, no,
No.
right?
No. No.
Until and
Yeah.
unless it's a very strong magnet, there are very
Magnet.
less
Yeah.
chances that it will attract it. Mostly it won't attract the nail.
Yeah. Most probably.
So what is the conclusion we get here? That around the magnet there is some region, there is some area
Yeah.
around which only if you keep the circular nails, sorry, around which only if you keep the iron nails, those will get
Mhm.
attracted towards the magnet. Apart
Yeah.
from that circular region, if I, for example, if I keep the nails here, these won't get attracted. These won't get attracted. Only if I keep in this circular region, it will get attracted. Okay. So scientists have this called magnetic
Magnetic field.
field. Okay. So any magnet kept here has a region around which if any other magnetic material, not only iron fillings, any magnetic material, for example copper or aluminium, if I keep them here, they will get attracted towards the uh, beyond that region. If I keep, for example, let's say I keep the substance here, they have no force here.
Mm-hmm.
Okay, is that clear? What is magnetic field?
Uh,
No.
the space surrounding a magnet where it produces a magnetic force is called magnetic field.
Yeah. Yeah.
Yeah.
Yeah.
Yes, sir.
Now uh, now have you seen this diagram before? Have you seen this diagram before? Okay, how do I plot? So there are two methods actually. The first one is called a compass method, plotting using a compass method, and the
Mm-hmm.
second one is called a iron filling method. Okay, we'll be seeing both the
Mm-hmm.
methods one by one. Have you done this iron filling experiments in school?
No, sir.
No.
No, sir, not yet.
Yeah. So have you seen a compass needle?
Yeah.
Have you seen this device?
Yes, sir.
So what do? We take a magnet. Okay, we
Mm-hmm.
take a magnet and we
Uh,
keep this needle here. Okay, and we
yes,
see
sir.
the deflection in the needle. You have a needle.
Uh,
So this has so wherever,
I-
sorry, or something like this. Okay, then
yes.
you again at this point you kept the needle. Okay, and you kept
Yes,
on
sir.
joining how the deflection was on the compass needle.
Yes, sir.
Whichever direction the compass needle was showing the direction, you kept on joining it.
Yeah.
Okay, and you got this circular field line at the end of the circle. I mean, you started from
Yeah.
here, every point you just kept on doing, and it
Yeah.
became an entire circle at the end of the south pole. So this is
Yes.
one way. This is one way using a compass method. This is one of the ways in which you can find this line. Okay, how this
Kind of. Yeah.
is what. Uh, so the other method is iron filling method. So in iron filling
Oh,
method, what do? You take a magnet, okay, and you throw
yes,
some
sir.
iron on it. Okay,
Yeah.
you throw some iron on it, so you will see iron fillings means like very small pieces of iron. Okay,
Yeah.
and you move the magnet slightly. You try to vibrate it. So you will
Uh,
see that the iron fillings are in such pattern. It's are always in these patterns
yeah.
uh, inside the magnet. Okay,
Yes, sir.
nobody has actually seen the magnetic field lines, how the lines work. Nobody has actually seen it. Methods are doing the compass method. We are just assuming that the force or the lines moves like this. That's the only thing.
Yeah.
Okay.
Yeah.
So, so this is a slight introduction